Welcome to Lesson 3's video on Unit 12 for an introduction to probability. We're going to find the theoretical and experimental probabilities. And in this lesson, theoretical probability is like a theory. It's something that we think about but might not be easily provable. It's just a theory that we have. Theoretical means that what should happen. So an example of theoretical probability is when you flip a coin, you should get the same amount of heads as you get tails, right? Because there's an equal chance of getting head and an equal chance of getting tails. So therefore, if I flip 4 coins, I should get 2 heads and 2 tails. But if I try to flip a coin, I'm just going to take I think there's well, let's just do a dice roll because that's what I have. In theory, if I roll 6 dice, I should get 1 of each number, right? If I just roll this 6 times. So I got a 4 the first time, I got a 2 the second time, a 5 the third time, a 1 the fourth time, but I got a 2 again. Now I should have gotten one of the numbers I hadn't rolled yet, but I got a 2 again. And I got a 1 again. You can see that sometimes when I actually perform the experiments, I get a different result. So experimental probabilities are what actually happened when I perform the experiment. So in your notes, you should write this down. Theory or theoretical probability is what should happen. So I should get each dice number after 6 rolls. And when I actually did it, I didn't, right? I got repeats. Now, probability is the chance or the percentage that something could happen. The chance that an event occurs. And it's going to be a fraction or percentage, okay? What's the most that could happen? 100% chance mean that it's certain to happen. And 100% is equal to just 1, right? 100 is 100. 100% is 100 out of 100. That's 1 as the chance is likely or certain to occur. So that you know for sure that if the probability is 100%, it has to happen. On the opposite side, if the probability is 0, if I have a 0 out of 100 chance, that means it cannot occur. It's not possible. But if the chance is 1 out of 2 or 50%, it's equally likely to occur or not occur. You express as a fraction, a decimal, or a percent. So for example, flipping a coin. What is the probability of flipping heads? This is an example. Flipping heads. Well, that's a 50-50 shot, right? It's 50% because it's equally likely to get heads or tails. Now, the way I calculate that in general, if all events are equally likely to happen, if it's a fair game, then it should be the probability of A happening. So the way I read this, if I see P of A, it's not a function. This is the probability or chance that A happens. Probability of event, we'll call it event A. And the probability, the way I calculate that as a fraction is all the ways A happens, depending on what A is, divided by all total ways. Right? So, for example, if I want to flip heads, how many ways can I get a heads? 1. How many total sides on the coin are there? 2. That's 1/2, that's 50%, or 0.5. Experimental probability is probability determined by performing an experiment, conducting a survey, or looking at the history of an event. So experimental is based on things that have actually happened. Theoretical probability is what I just calculated with probability of A. So here's an example. A spinner, if you don't know what a spinner is, it's a giant wheel, has 8 equal-sized sectors that are numbered from 1 to 8, like this. Find the probability of A spinning a 6 and B spinning a number greater than 5? Well, for part A, if I want to spin a 6, the probability of calculating a 6, so the probability that I get a 6 would be how many ways to get a 6 over total possibilities. So how many ways can I get a 6? Well, there's only one way. There's only one 6. So 1, and what are the total number of possibilities if I have a spinning arm on this? So if you don't know what that means, it's like you have an arrow that's going to spin around. You're going to just take this arrow and move it around the hand of the spinner here, and wherever it lands on, that's what number you get. And so there's only one way to land on a 6, and there are 1, 2, 3, 4, 5, 6, 7, 8 ways. So the chance of getting a 6 is 1 out of 8, which in your calculator is 0.125. And to make that into a percentage, you move the decimal 2 places to the right, and you get 12.5%. Now let's do part B. Part B, okay, part B is how many ways can I get a number greater than 5? Well, how many numbers are greater than 5? And not equal to 5, but greater than 5. So I can't count 5. There are 6, 7, there's 3 different ways to get numbers greater than 5 out of 8 total numbers I can land on. So 3 out of 8 is the fraction, or is 0.375, or 37.5%. Any one of these formats is fine. I don't care if you leave it as a fraction, a decimal, or a percent. Sometimes a percent is useful to compare it to other different fractions or percents. Now let's think about a deck of cards. One card is drawn from a standard 52-card deck. Find the probability of drawing a spade. Well, you have your sheet of paper with all the cards on it. How many spades are there in a deck? So probability of getting a spade, for example, and again, this is the spade. Probability of getting a spade is however many spades there are, so how many spades over total cards. That's how I'm calculating this. I take how many total spades I have to choose from by total cards. And I divide. Well, there are 13 spades and 52 total cards. That is 1 out of 4. If you choose to do it as a fraction, I expect you to simplify that fraction, or just divide and make it a percentage or a decimal. So it's 1/4 or 25%. Now the probability of getting a 9 or a 10. So the probability of getting a 9 or a 10, we'll have to count how many 9s or 10s they are. So 9 or 10. Well, there are 1 in every suit for 9, so that's 4 9s. And there's 1 in every suit, a club, a diamond, a heart, a spade, for 10s. So that means there are 8 possible 9s and 10s out of 52 cards. And again, if you choose to write it as a fraction, I expect you to divide by the greatest common divisor, which in this case I believe is 4, to be 2 over 13. And if you divide in a calculator, 2 divided by 13, you get 0.153, and that means you're going to get 15.3%. What's the probability of getting a face card? Now, a face card is going to be a jack, a queen, or a king, because they have actual people on those cards that have faces. So how many are there in the deck? So probability of getting a jack, king, or queen, how many are there? There should be 12, because there's 3 in every suit. There's a club, a diamond, a heart, a spade for each of these cards. So that means there's 4 of each out of 3 different cards. 3 times 4 is 12 out of 52. Again, you must divide by the greatest common factor. I believe, again, it's 4. This would be 3 out of 13. And so in your calculator, to figure out what that would be, 3 out of 13, it's 0.231, or 23.1%. So you can compare which one's more likely. Obviously, it's more likely to get a face card than a 9 or a 10. Now, let's say you made 15 of 21 free throw attempts. Find the probability that you'll make your next free throw. Is this experimental or theoretical? Am I going off of what's actually happened, or am I just calculating what should happen in theory? Well, the correct answer is that this is an experiment. We've done the experiments. You've already shot these free throws. And assuming that you perform the same every single time, which doesn't always happen, but experimentally, you made 15 successes out of total attempts. 21 total attempts. So we're going off of that data to predict the future of what happens next. And again, you have to reduce this fraction. What's the biggest common divisor? It's 3. It'd be 5 out of 7. That's your chance to make the next one based on your previous success. And there's no other way to know this except based on the previous success. So it's about 71.4% chance that you'll make the next free throw based on what you have. And this happens in sports all the time. If you follow baseball or football or any other sport where they keep data, they'll tell you what the person's pass completion rating is. They'll tell you what their batting average is, what's the likelihood that they get a hit. And it's all based on, what they've done in the past. If you're a batter in the major leagues and you haven't taken a swing yet, you have no batting average. But if you make your first hit, then you're 1 for 1, which means you have a 1,000 batting average because 100% of the time you get the ball hit. But let's say you went up to bat 5 times and you only hit 3 times. Then you have 0.600 batting average. Okay? Thanks for watching. I'll see you the next day.